All right, guys. This is problem number 2. This is a really challenging problem. You have to think about this one a lot. This is much harder than will be on the test, but I think it's good practice for you. Okay, so here we have f, which is this crazy-looking function, and it makes R, which is the region in the second quadrant, bounded by the graph of f and line L, tangent line of the graph as shown. So this is line L, and the first problem that I noticed was they don't even give you the equation of L, and we actually are going to need it later on. So when I go ahead and I talk about line L, which is this red line that comes down, we're going to have to find the equation of that line. We also need to find the first thing we need to do is find the area of region R. So region R is pretty straightforward. We have the equation for the curve that makes the top of region R. And if we want to find the area for it, I'm going to personally go ahead and fill it with those vertical strips again. And since I filled it with vertical strips, I'm going to write dx, because that's what I need for vertical strips. And I know that the region goes somewhere from here up to 0. I can see that on the graph. Question is, what is this intercept down here? So the first thing I did was I graphed this function. I did a zoom trig, and the reason I did that is because I saw my cosine of x in there. Make sure your calculator is in radians. That's really important. And when I did that, I was able to see this curve. It looked exactly the same, and I was able to do a second calc 0, and I was able to find this 0 here. And when I did find that 0, as I said, by all means, feel free to pause me and make sure that this actually works for you. This is negative 1.3733122. So that's what this x value is right here. Okay, so I'm going to put that in right here because that's where region R starts. Negative 1.373122. Now the top of my strips touch this crazy function. I'm going to call this function f of x because I really don't want to keep writing it over and over again. And the bottoms touch 0, the x-axis, So if I just integrate from negative 1.373122 to 0, my function, I get back the area underneath R, which is 2.903. And I'm using my calculator to do this, of course. All right, next, we want to find the volume of the solid generated when R is rotated around the line y equals negative 2. Well, y equals negative 2 is somewhere down here. Let me switch colors for a second. Y equals negative 2 is down here. So I kind of imagined if this was down here, it would look kind of, like this, something like this. And it's not going to be a solid. It's clearly missing some space right in here. So that's when I go ahead and I'm like, all right, I'm going to have my washer method, which means I'm going to have a big R and I'm going to have a little r. My big R, to find them, I'm going to start at my axis of revolution. I'm going to go as far out as I possibly can. That's this curve. So the top of this curve is the function f of x minus the bottom of the curve touches negative 2, so minus negative 2. So basically this is f of x plus 2. That's my big R. And my little r starts at negative 2 and it goes out to here. We're never going to get any closer than right here. So that's 0 minus negative 2, which is just positive 2. So to find the volume of the solid generated when it's rotated around that line, it's a horizontal line, so I'm going to keep everything in terms of dx. It goes from what we just showed right here, negative 1.373122 to 0. Those are my x values. And it's the function plus 2 squared minus 2 squared. Now, I'm going to show you how to put this function into your calculator so you don't have to keep retyping the calculator. But for those of you that do know what I'm talking about, when I do the Math 9 FNINT, I'm putting bars, y1, so I don't have to keep rewriting that function over and over again. Don't forget about the pi up front. That's really important. So when I type this all into my calculator, I get 18.8953, and that's pi. I'm not going to forget about that pi. All right, option C. Write but do not evaluate an integral expression that can be used to find the area of S. All right, well, the area of S is kind of annoying because it's in between this line that we still don't have an equation for and the curve that we do have an equation for, but it's not nice to watch. So let's look at what S is. S is actually this line that is the top of S is the line tangent to the graph at x equals 0. All right, so here we are testing your ability to write an equation of a tangent line at x equals 0. Well, in order to write an equation of a tangent line, you need to find f of 0. You need a point, and that's 0. If I plug 0 in here, we get 0 minus 0 minus 0 plus 3 times the cosine of 0. And the cosine of 0 is 1. So 3 times 1 is just 3. There's my point. And I also need a slope, right? The slope. Well, the slope is f prime of 0. So let's take the derivative of this. Derivative of x cubed is 3x squared, so it's 3/4 x squared minus, this is x squared over 3, I believe. And so that would be 2x over 3 minus 1/2, because this is 1/2 times x, plus the derivative of cosine is negative sine, so negative 3 sine of x. All right, if you plug 0 in for x there, this is going to be 0, this is going to be 0, this is going to be 0. So all we have left is our negative 1/2. So let's write the equation of our line L. Line L will be y minus my y value equals my slope times x minus my x value. And if I just add 3 to both sides, I get y equals negative 1/2 x plus 3. That's the equation of line L. So the integral expression to find the area of S, just like for part A, if we imagine our space filled with all of these vertical lines, we're going to go from, they're vertical lines, so it's going to be dx. The top equation is this equation, negative 1/2 x plus 3, minus the bottom equation, which is my function, f of x. Now, where does this region start? It starts over here with an x value of 0, and it ends over here with an x value that I need to find out. And so what I did was I graphed my second equation on my calculator. I did second calc intersect. I did first equation, second equation, and found out that over here, the number where they intersect, this x value is actually 3.3898677. And when I went ahead and wrote that in up here, 3.3898677, I'm done with part C. All right, last but not least, we want the region R is the base of a 3D solid. The cross sections are isosceles triangles, and we need more information here. I will not give something this vague on the test. This would need to say with bases in the plane. All right, that allows me to make this a little bit easier. If the bases are in the plane, now think about an isosceles right triangle. If the base is in the plane, and this is like some number, we're not sure what it is, well, since the formula for the area of a triangle is 1/2 base times height, and since it's isosceles, they'll both be x, and so it will be basically 1/2 whatever the base is squared. When if the base is in the xy plane, the base is going to go from the top to the bottom, which is really f of x minus 0. So to find the volume, we're going to integrate the area, dx, and that's going to be, the area is going to be 1/2 base, which is f of x, times height, which is f of x, dx. So when I put that in my calculator, and I'm going to do this, the same bounds I did before when I talked about region R, which was from negative 3.73122 to 0. Basically, this is the function squared, so I just put in the function and then squared it. I get 3.641472278. And that's your answer. All right, good luck.